today. I'm doing another video on time. What about time? This is going to be a short video, but it's an introduction video about things that happen in advanced physics. The best way to learn something is to go to the best theories that represent that what you want to learn. So I did that. That's called advanced physics, modern physics. There are different types. One has to do with space travel. It seems to click to my mind. I don't know why. But anyways, we have a problem in physics. What's that problem? The speed of light. Originally, relativity was developed by Albert Einstein. The speed of light is constant, can't go faster. In my videos, in my mind, I guess, you can go faster than that. Some theories like Hubble universe, you can go faster than the speed of light. But it's not been connected to the books. There's no conformable, adaptable theory that says we absolutely can go faster than the speed of light. Well, Albert Einstein created what's called general relativity. Now, general relativity is a real look at space travel. His first book was Special Relativity, which was a imaginary journey through space at the speed of light. How it would be if I could travel at the speed of light was his conscious thoughts. Later, that became general relativity. In his book, in his theory, we have the speed of light, 186,000 miles a second. His theories conform this speed limit, which they call c, in E equals mc squared, to conform that under a traction gravity field, you can only go 93,000 miles a second, which is 50% the speed of light. And you can only go that fast, putting out 186,000 miles a second of force. And you can only go 93,000 miles a second because you gain mass. See, Einstein was good at explaining his philosophies. You gain mass as you travel, try to go higher and higher. The energy conforms, and it gets greater. So you can only go, because of gravity, half the speed of light. But here's the kicker. He doesn't change the time sequence to the speed of light. Now, the speed of light is the speed of light. Anything slower than the speed of light, which is m, whatever it is, its weight, conforming to that velocity, that's what E equals mc squared is, you gain a certain amount of mass due to gravity. Actually, the formula is just the opposite, but without going deep into it. So anyways, we can only go 93,000 miles a second because of the attractive force, which is gravity. But he did nothing with the time. If the mass increases during an acceleration through space or through a gravity field like Earth's gravity field, that's our example format, time has to change too. So you don't have just 186,000 miles a second. You have 186,000 miles and you have a second. So if you can only go 93,000 miles an hour, I mean a second, then you can't travel the speed of light in a second. It would take you 2 seconds, because you're conforming to the gain of mass, which is 93,000 miles a second. And to reach the speed of light, you'd have to do it. You would slow down in that one equation of 93,000 miles a second. To actually travel the 186,000 miles, it would take 2 seconds. Because you're gaining mass. It's getting heavier. Everything is slowing down as you gain this mass. And the way physics is written, E equal mc squared is supposed to make it veritable to all velocities and all masses and weights. But to travel, if you can only go 93,000 miles a second, you gain mass. Time slows down as well. That means it's going to take you 2 minutes or 2 seconds to travel at the speed of light. Not 1 second. So the confirmation of Albert Einstein's idea on whether you can travel up to the speed of light is broken down into masses. That's to say that can you travel at the speed of light at 93,000 miles a second in 2 seconds, because that's what it would take. Then you have 3 seconds and 4 seconds and so on. But this is just a little introduction to the theory. What you do to one thing, you have to do to the other. So, for the equation to be complete, you'd have to travel 93,000 miles for 2 seconds with enough force that it equals 186,000 miles a second. And to do that, it takes 2 seconds. My name is Rod Kowicki. Thank you. So let's rethink what we just talked about. Relativity, Albert Einstein believed we could travel into the future or the past because time slows down. I believe that he might have made this big, this chronological evaluation later on in his life, after he did wrote his books. Because a mass slows down because it's accelerated through a gravity force, an attracted force like we have here on Earth, and the variables are the speed of light, and you can only travel at half the speed of light because of gravity. Everything slows down. But that's only each second of time it slows down relative to that velocity and that action, which is the action of half light speed. That doesn't have to do with the world itself, the universe itself. The universe doesn't, when we die, the universe don't die. The universe lives on. We are just part of it right now. Without going any really deep into that, I think this is where Einstein thought that since time slowed down like that, we're talking about a mass slowing down relative to a velocity. Now, how that lingers into time travel, because time slows down relative to each second per second. He engaged his whole theory on the speed of light, which is c. He promoted it as a constant. We know it's not a constant. Hubble's theory. But even if it was, it's only a description of activity each second of time. If that's relative to the speed of light, and according to Einstein, we can't go faster than the speed of light. To do so, according to Einstein, means we travel into the infinite future or the infinite past. If you know that theory. That's a long time. But we're talking about something that slows down relative to its equations in an attraction field. My other work is basically on repulse gravity, which is space supergravity. Supergravity has no attraction. It's a repulse force. It helps you, pushes you along. It says, whatever you can go, I'll make you go faster because I'm here. You got a river that's going 50 miles an hour, and you're on that river, you're going 50,000 miles, 50 miles an hour. Now you got an engine, and you click in that engine. Do you go faster than that? I think you do. Think about it. You're going 50,000 miles, you got an engine, and you hit that engine. I think you're going 75 miles now. Because in space, you see, it's not like on a river you feel things. See, you would think, well, you'd have to go 75 miles an hour, because the river is going 50, and to go faster than that, it has to be put at a calm, and then you have to go faster than that to go 75,000 miles. This is what Einstein did with this train to make it 75 miles an hour. See? But in space is calm. Space is a pressure. It's already built up. It's already there. It's just going to help you along with your own footwork. In other words, you got an engine that goes 50,000 miles an hour. You're going to go 100 just because there's nothing holding you back. So whatever velocity you go, you're going to go faster. Like I says, Einstein's train ain't all the people think it is. It's complicated, very complicated, I hate to say. My name is Rod Kowicki. Check out my videos, man. I got a lot of them. Got a lot of physics, if you want to understand. Of course, understand this is a new theory. It's published, but it's not in your schools or universities. It's an independent study. They should be in all your schools. My name is Rod Kowicki. This is NASA X.